Okay, this is solving linear systems for grade 10 mathematics, NPM 2D, and we're looking at first of all using a graph to find the intersection of two lines. I've already found the intersection of the lines here. You can see they intersect there, and you can just read that point off the graph. It looks like 2 and a bit, maybe 2 and a quarter, and maybe this is about 3 and a half, so the solution would be 2 and a quarter, 3 and a half. Let's look at how we would actually graph those lines though, so that we could read off that intersection. Very important, you do a separate table of values for each equation. So here, equation A, 2/3 x plus 2. You do a table of values for that. Pick a couple of values, spread them out a little bit, but keep them fairly close to the origin. I've used 0 and 6. So for instance here, x is 0 gets put into the formula for A, and the formula for A was y equals 2/3 x plus 2. So there goes 0, it gets subbed in there, and the result is y equals 2. So when x is 0, y equals 2. And you follow that method here again. If you put 6 into this formula, the solution that would come out would be y is 7. And that again is another coordinate, 6, 7. And there you can see 6, 7 is being plotted, just like here. I plotted 0, 2. So you repeat that procedure for line B. You pick a couple of x values, try 0. The initial value is always good to know the b value or the initial value. When x is 0, you put it into this formula, and you can see the constant just comes out, the b value. You got y is 5. There it is, 0, 5. You could also pick x is 3. So again, you plug 3 into that equation, and the result here would come out as y is 3. And there you can see, again, I've plotted 3, 3. That's the coordinate 3, 3. After you've done that, it's just a matter of reading off graphically where they cross over this point. Now, as I've said before, geometry is good, but it depends on how good your drawing is, and the algebra is perfect. So preferentially you would want to use substitution method or elimination method. You would want to check these using the algebra. So here we have, there's the two lines, equations, A and B, and because they're both equal to y, they're both equal to each other. So what I'm going to do is, see this y in equation B, I'm just going to substitute that off and substitute in its place 2/3 x plus 2. And here we have then 2/3 x plus 2 equals minus 2/3 x plus 5. So instead of y equals, I'm using this, because they're the same thing anyway, right? So subbed the y off and put that in its place. And the reason you do that is you get an equation with only one variable in, just an x value. So if you've got an equation with just one variable, you can collect the like terms. So here, I've put these x's on the left, this number on the right, x's on one side, numbers on the other. Simplify that to 4/3 x is 3, and then just multiply the 3 up there, divide by the 4, and you get x is 2 and a quarter, which seems to confirm what we found here. X was about 2 and a quarter there, wasn't it? So you can see the algebra seems to have confirmed that we were on track there. Let's see if we were on track here. This looks like sort of 3.75. We'll take the x value down here, and we'll put that x value back into one of the original equations. So here, for instance, y equals minus 2/3 x plus 5. We shall replace that, or possibly in this one. Let's take this one, and we'll say, we'll sub in x is 2.5, x is 2.25, 2 and a quarter, in there. So when you do that, you can see what happens is you will solve for y, and you get y equals 3 and a half. So what we've got actually is a full solution here. We've got x is 2 and a quarter and y is 3 and a half. So they together are the coordinate of the intersection. That is the graphical solution.